A single phase line of 250 volts 50 Hz has conductor spacing of 1.5 meters. The diameter of each conductor is 1.5 centimeters. Calculate capacitance of the line in microfarad for a length of 50 kilometers and the charging current. So this is a single phase line. So we can either use the direct formula C is equal to pi epsilon naught by ln d by r, right, where d is the distance between the two conductors. This is d and r is the radius of each of the conductors. Okay. Otherwise, we can also use the GMR formula, right. So, or using GMR formula. So, according to that, it is C is equal to 2 pi epsilon naught ln GMD by GMR. This is for each conductor. So, what will be for both conductors? For both conductors, that is the total capacitance. The capacitors are in series. So, when they are in series, how will you find out the equivalent capacitance? 1 by C plus 1 by C. Okay. So, C equivalent is equal to C by 2. So, this is going to be pi epsilon naught by ln GMD by GMR. Okay. But for a single phase line, what is GMD? It is simply the distance between the two conductors. D divided by GMR is nothing but the radius. So, R. You can see that this is same as this expression. Okay. So, now what is this value? If you substitute, C equivalent is equal to pi epsilon naught divided by ln D is given as 1.5 meters and diameter is 1.5 centimeters. Okay. So, we can either write in terms of meters or centimeters. So, if you take in terms of centimeters, 1.5 meters is going to be 150 centimeters divided by radius is going to be 1.5 centimeters divided by 2. Okay. And here what is epsilon naught? 8.85 into 10 to the power minus 12, right. So, if these values you are going to substitute, then you are going to get 5.247 into 10 to the power minus 12. This is farad per meter, right. Now, we want the total capacitance of the line for a length of how much? 50 kilometers. Okay. So, 50,000 meters, because it is in kilometers, we have to convert into meter. So, C for line length of 50 kilometers. This is going to be 5.247 into 10 to the power minus 12 into 50,000. This, if you calculate, you are going to get 0.262 microfarad. Micro means 10 to the power minus 12. So, this is the total capacitance for the single phase line of 50 kilometer length. Next, what do we want? This is the first bit of the question. Second one is the charging current. So, here charging current expression we have already seen. This is going to be J omega C into V. So, here if you only take the magnitude, charging current is going to be omega C V. The frequency is given as 50 Hertz. So, 2 pi into 50 into capacitance we found as 0.262 microfarad. So, into 10 to the power minus 6 into the voltage is given as 250. Okay. So, this you are going to get 20577.43 into 10 to the power minus 6 amperes. Okay. So, you can write in terms of microamperes or milliamperes. So, in milliamperes it is going to be 20.57 milliamperes. The three conductors of a three-phase line are arranged as shown in figure. The diameter of each conductor is 2 centimeters. Find the capacitance per kilometer to neutral if the lines are transposed. and this is the configuration that is given. It is a horizontal configuration, right? So once it is given that the lines are transposed, then you don't have to worry. All of the capacitances, any phase you take, the capacitance is going to be equal. The line is not transposed and there is unsymmetrical spacing, then the capacitance per phase will not be equal. Okay. So here what is the expression? Using the GMD GMR concept, the C per phase per meter is going to be how much? 2 pi epsilon by ln GMD by GMR. So what is GMD here? This is the geometric mean of the distances between each of the distances between the phases, right? So one distance from A to B is 4, from B to C is 4, and from A to C is 8, right? So GMD is equal to 4 into 8 to the power 1 by 3. This, if you calculate, you are going to get 5.039 meters. And what about GMR? This is nothing but the radius of each conductor. There is only one conductor in one phase, so it will simply be the radius. So this is going to be, diameter is given to be 2 centimeters. So radius is 1 centimeter. So now you can find out the capacitance per phase per meter, 2 pi epsilon naught divided by ln 5.039 meters divided by 10 to the power minus 2 meters, or you can write 503 centimeters divided by 1 centimeter. Thus you are going to get 8.939 into 10 to the power minus 12. This is in farad per meter. Now we want the answer in kilometer, farad per kilometer, right? So this will be 8.939 into 10 to the power minus 12. Instead of meter, you can substitute 10 to the power minus 3 kilometer. So that 10 to the power minus 3 is going to become 10 to the power 3 when it comes to the numerator, right? So farad per kilometer. So you are going to get 8.939. So instead of 10 to the power minus 9, we will write as nanofarad. Nanofarad per kilometer.